Hey all, this is the second part to that factoring and solving rational equations packet that I gave you for homework on Friday. I want to go ahead and start off with how do we solve rational equations. Everybody say hello to Autumn. Autumn, say hello to everybody else who's going to watch this video.
Thank you.
Say hi, not thank you.
Hi.
Autumn is with me as I, do my video because I'm a mother and she exists. She's 4. She's going to help me with some of the numbers. All right. Solving rational equations. The first step is to identify your least common denominator. This is key. You need to write it out to the side. I'm going to write mine outside every single time when I do this problem. Once you find your LCD, you need to look at or identify your domain restrictions. Now, I am not going to write that down as a step because I'm going to come back to it at the very end when we're checking our answers to see if they're extraneous. So, just know that. But our second step will be to create your least common denominator so that you can eliminate your common denominator.
That comes down to a few, though?
So once we eliminate our common denominator, we just solve whether it's a quadratic or a linear. Whether it's a quadratic or a linear, it depends on how you're going to solve something. You're going to have to know how to solve both. We've been working with quadratics for a long time. You need to be comfortable with that. That's why we did the factoring in this first part. Okay, so you know how to do this. After that, you need to check your solutions with your domain restrictions. Check your solutions with your domain restrictions. And that's really the gist of what we're doing. I like solving. This is one of my favorite parts. Okay? This is actually one of my favorite parts. I love anything where we're solving. So let's get started. Number 31. Okay? If you're looking at number 31, number 31, can you say number 31, Autumn?
Number 41.
All right, number 31. We have to find, what's my first step, Autumn? Find the least common denominator, LCD. I told you I was going to write it out every single time. My LCD, they all share an x squared, and the largest one has a 4x squared. So I need to multiply everything and get everything to what? 4x squared. So let's begin to see how we do that. I'm going to write this out to the side so that I have more space. X plus 4, 2x squared, plus 1 over 4x squared is equal to 1x squared. All right, here we go. What do I need to multiply this first fraction, x plus 4 over 2x squared, to get a common denominator of 4x squared? Well, I'm going to multiply this by simply 2. This next one, 1 over 4x squared, do I have to do anything to it? No. Ladies and gentlemen, it matches. Don't do anything. And then this one, x squared, what do I have to do to get it to match 4x squared, Autumn?
I don't know.
Look at the 4. What do we need to do? Multiply it by what number?
5.
Good try. 4.
4.
Yes, that's how old you are, remember? Okay, so this becomes, since we have the common denominator, you do not have to write out the denominator again. We can simply now cross that out and look at our numerators. 2x plus 8. How did I get that? I took that 2 and distributed it into the parentheses that are imaginary, okay? But I took it to every single one of those terms. Plus 1 came from right there, equals 4. So this creates a linear function. I'm going to come up here, ignore all this, and I'm going to solve it. 2x plus 9 equals 4. Subtract 9 from both sides. 2x is equal to a negative 5. Divide by 2, x is equal to a negative 5 halves. Is this a solution? What would be my domain restriction for this original problem? The domain restriction for this original problem is going to be what? Since it's simply x squared, x can never equal 0. So this right here is in fact a solution. That's the first one.
Hey, Mommy, look.
Okay, number 33. I made it a little bit larger, so hopefully this will help us a little bit more. Number 33, we're dealing with a squared, 3a, and 3a squared. So what would be my LCD? If you said my LCD was 3a squared, well, you're absolutely correct. So how can we get everything to match the 3a squared? How can I get that common denominator? So let's check it out. If we take this, again, I'm going to rewrite it so that I have more space. Just because, again, you guys, you want to give yourself the most space possible. If we look at this to figure out what it needs to do, let's start with the left side, 2 over a squared. How do I get this to match 3a squared? Well, I'm going to take this and simply multiply it by 3. This one, I'm just simply missing an a. And then this one, I'm just simply missing anything. Am I missing anything? No. So, don't be afraid to kind of get in a roll and see what you got. So, since this is all good to go, 6 is equal to a minus 1. That's nice. Why? Because look, plus 1 plus 1, a is equal to 7. Check your domain restriction. What is it going to be? A can never equal, it's a and a squared, 0. That's it, you guys, that's it. So that is your solution. Next one, number 35. 2 plus m plus 3 over m equals 1/2. Well, this is kind of tricky because right away you can't really see what my LCD is going to be. Remember that whole numbers are automatically what? You should always imagine them over 1, okay? You can always put any whole number over 1. So, out of 1, m, and 2, what would my LCD be? My LCD will be, that's right, 2m. So, like I have been doing, I'm going to rewrite it. And I'm going to have 2 over 1 plus m plus 3 over m equals 1/2. How do I get this stuff to match? Here we go. The first one, we need to multiply both 2m on both. And then over here, all I got to do is multiply it by 2. And this one, we're simply going to multiply it by m. So we get, these are all the same, 4m plus 2m plus 6. Do not forget that it goes into that 3 as well. Equals m. We got to do a little bit of rearranging. 6m plus 6 equals m. My suggestion, move the m to the right side. 6 is equal to a negative 5m. And you get, divide by negative 5, divide by negative 5. I don't know why I did 2 negatives there. So your solution will be m equals negative 6/5. Is that an original domain restriction? M cannot equal 0. So we have checked it off. That is your solution. All right, 37. My LCD. This one's actually probably the easier one out of the one that we just did. Again, put 1 over 1. Even if it's 1, just put it over 1. Your LCD is going to be, you guessed it, B. You have a B here. Only thing that's missing is a B there. So we're going to have 5B equals 1B. And since both of these have a B, I'm going to go ahead and just simply understand that this is going to be a B over B. Why did I do that? Because I'm going to be multiplying this by B over B. There's no point to just, you have to understand that 1 can be just B over B. So now the denominators match. You get 5 equals 1 plus B. Subtract 1 from both sides. B is equal to 4. Domain restriction, b cannot equal 0. It's the same. We've had really easy domain restrictions, so b is equal to 4. All right. The last page, 39 through 46. These are where I up the difficulty, and you really need to start paying attention to a couple things. All right. The least common denominator. This is going to be where it's kind of hard to find. You really have to pay attention to what's going on. Okay. And if that means you have to factor your denominator first, then you need to do so. If you notice this right here, this is your largest denominator. Why did I say that? Well, it's got a highest degree of 2, and you have a v right here. Since we have a v squared, this has a degree of 1, that has a degree of 1, so it's missing that. So when I come over here to do my least common denominator, I'm going to automatically look at this one right here. Okay? That's going to tell me where I'm going to go. This is where I need to look at to see what I need to do for the least common denominator. So how do I do that? They both share v, so that's why we're factoring again. That's why we're stressing factoring so much, because now you can see this piece matches this piece, and we're close on this piece. It matches what? If you said the v out front, then you are correct. Those match. So we have to look at what my least common denominator is going to be, and that's going to be v plus 3. If you say v squared plus 3v, that's acceptable as well. I don't care. You just need to know, you need to be able to see it at all times. So here we go. Let's rewrite this. 4 over v. I'm going to multiply that by, you guessed it, v plus 3 over v plus 3. That is going to equal 1 over v times v plus 3. Do I have to do anything to this? No, thank goodness. I don't want to do anything to that. And then last but not least, this 1 plus v plus 3. The last thing we're going to do is take that and multiply it by, yep, you guessed it, v. So we get all common denominators. We can cross them out. Here we go. 4v plus 12 equals 1 plus v. This is a little bit harder of an equation, but you can absolutely solve this. I'm going to take my v and I'm going to put it over here. So I'm going to subtract 4v from both sides. And then I'm going to take that 1 and I'm going to add it to both sides. Okay, this crosses out. And then the other side crosses out. I'm doing it all in one step. Please do not get confused. It's okay. I'm simply just combining some steps. So we get 13 equals a negative 3v. Divide by negative 3. v is equal to 13 over a negative 3. What did I do? Ah, look at this. That's not correct.
Nope. Not the correct.
No, it's not correct. What did I do, Autumn? I should have subtracted instead of added. You are absolutely correct. Good job.
Way to go, Autumn.
Good job, Autumn. All right. So this becomes 11 equals a negative 3v. Divide by negative 3. The answer should be b equals 11, negative 11 thirds. Is that the answer now on the back? Yes.
Yes.
It's very easy to get that wrong.
Yeah.
What's your original domain restrictions? V cannot equal negative 3 or 0. V right here is 0 and this one's a negative 3. Does any of that qualify? Nope. So our answer is good. Okay, next one, 41. Take a look at this x squared minus 1. You're going to try to tell me, oh, I can get this to equal x squared minus 1, but you cannot. X squared minus 1 is what, Autumn? Difference of squares. Very good, because 1 is a perfect square, and x squared is a perfect squared. So that's why our LCD is going to be x plus 1 times x minus 1, or x squared minus 1. Remember? x squared minus 1. That's what it factors to every single time. So, next what we're going to look at, rewrite it. How can we get this to match? I'm going to leave myself some space. Luckily, I have been nice and given you nice examples. It's really progressing, so hopefully this is helping some of you. I'm going to take this and multiply it by x minus 1. And do I have to do anything else? No, that's the only thing you have to do. Once you have that, it matches. So we can eliminate the what, Autumn?
Eliminate
the denominator.
denominator.
Very good. So this becomes 2x minus 2 minus, what number is that right there?
1.
Very good. Equals 4x minus 8. Combine like terms. And we get 2x minus 3 equals 4x minus 8. I'm going to move my 2x over to the right. So I'm going to subtract 2x from both sides. This becomes a 0. And I'm going to add 8 to the left side. So my resulting equation becomes 5 equals 2x.
2x.
Divide both sides by 2. X is equal to 5/2. What's my original domain restrictions? My original domain restriction, x cannot equal plus or minus 1. So is that greater than 1? Yep. We're good to go. All right. Last but not least, I'm going to go ahead and do number 45. I'm going to skip 43, even though that's a good one too. But I want to go over 45 since we get a fraction. Okay? So, here in 45, what's my least common denominator? If you said n squared, then you're correct. N squared, n, and n. It's pretty basic, all right? Hopefully you should see that. So we get 2n plus 2 over n. How do I get it to match? I'm going to multiply both this by n over n. Do I have to change this at all? No. So this becomes 1 over n, so all I got to do is multiply that by n over n. We have the same denominator, so these can cross out, giving me the resulting equation. It's fine. They're fine. Sorry, you guys. I'm recording right in the middle of math time. All right. 2n squared. All right. I'm back. Take that n and distribute it into both terms. That 2n plus 2, you have to distribute in there. So this becomes 2n squared plus 2n minus 1. Oops. Equals. Sorry. There's an equal sign, not minus. I crossed it out. I didn't see it. 2n squared plus 2n equals 1 plus n. Now, because we have this n squared, this becomes a quadratic, so you must set everything equal to 0. Again, you must set everything equal to 0 to work with it. So I'm going to take this entire thing and move it to the left side. This becomes 2n squared. I'm going to subtract n. So plus 1n minus 1 equals 0, because I'm subtracting this as well. So now we have the quadratic. Since the leading coefficient is greater than 1, we're looking at 2 here, and then excuse me, a negative 2 here, because 2 times a negative 1 gives you a negative 2, and we're looking at the two numbers that will give you 1. 2 and negative 1. Hopefully you saw that, because this is a very basic number. The only factors of 2 are 2 and 1. So that's why I knew how to do that. 2n squared, 2n, a negative 1n, and then finally negative 1. Again, you can look at these top numbers. What do they share? They share a 2n. And then this, they share a 1. It has to be a negative n. Negative 1n, technically. So, Ooh, no, don't do that. Don't take the negative. My fault. Just simply they just share what? An n. Yes, Miss Smith is tired. All right. So this becomes a -1 down here because they both share. If you look at that, I'm not even following my own advice. Whew. They both share a negative, so you can pull out a -1. And then last but not least, we have a 2 up here, if I can switch back to the pen. So my parentheses become 2n minus 1 times n plus 2 all equals 0. So since this is a quadratic, we have to solve. We have to set those. We just can't factor. We have to now solve those. How do I do that? I'm going to erase this so I have space. I'm going to take the 2n minus 1. I'm going to set it equal to 0. Add 1 to both sides. And then divide by 2. Okay, so 2n equals 1. Divide by 2. N is equal to 1/2. Now, n plus 2 is a little bit more. You should know that. So, oh, you can't even see the 1/2. You should be able to see that -2 is your other solution. Now, you guys, I just noticed my answer is incorrect. My factored form, I don't think I wrote correctly. This should have been a 1. That's how you know I'm tired. So this should have been a -1. Okay, and those are your solutions. Now, does that match your original domain restriction? The original domain restriction would be n cannot equal 0. So those all check out. If you have questions, let me know. Come to me tomorrow. I can help you through some more of these. All right, you guys. I'm done.